Okay, sorry guys, I forgot to hit record, but the question was, what if you had to balance a redox equation that had an overall charge of negative on each side? I'm going to change my numbers a little bit too. So I had 3 plus aqueous, and then I'll go C, let's say, no, let's keep it the same, 7 negative. Okay, so like I was just mentioning before I hit record, the first thing you want to do is get the overall charge on each side. Now remember one thing, guys, if you see a chemical, like H2O, if it doesn't have a charge, it doesn't contribute. So don't worry, like you're only adding charges if they're there. So H2O doesn't have a charge, so I'm not going to worry about it. So the charge on this side is -3, or in chemistry, we would say 3 negative. Let's say -3. And on this side over here, it would be +3, or 3 positive, and a -7. Put them together and you get a -4, right? You can do that on your calculator. 3 plus a -7 would give you a -4. So the question is, where do I put my electrons to balance this out? Both sides are negative. Where does my electron go? What do you guys think? In the chat, left or right? Left or right?
Left.
Okay, let me check the chat before I say anything, before I tell you if you've been correct or not. Yeah, left. So yeah, and so in the chat, everybody left, 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 left. Yes, exactly. Perfect. Okay, sorry, I got a private message there. Okay, now for anybody who doesn't know why it's left, think about what adding an electron. Okay, adding an electron is just adding a -1. You need to make these numbers equal. -3 and -4 need to somehow turn into the same number. And all I can do is I can add a -1 to any side. The only way that that's going to happen is if I add a -1 on this side. So I'm going to add 1 electron here. Now, if I do my overall charge, I have -1 and I have a -3. So that's -4. They're equal. I don't think your final exam one is that hard, but that's a really good question.
Thank you so much, sir.
No problem. Okay, just before anybody interrupts or says anything, I have 13 people here, which is amazing. I just want to mention something. I'm not going to go too long tonight because it's just been the busiest weekend ever. I know you have your exam tomorrow. You should be studying. For anybody who came tonight expecting like this crazy big epic, let's go through the exam tutorial, we did that on Thursday, meaning you should go and check out Thursday's video on my YouTube. What I want to do tonight is answer your burning questions, something you really don't understand that I can hopefully help with. So anybody else have a question? And you don't need a specific question. You can just say, I cannot do titration. I cannot do polymers, whatever. And honestly, if nobody has a question, I can do some things I think that are important, but like ask me questions, please, please, please. I don't know why my mouse isn't working. Okay. Anything? Nothing? Oh, here we go. I got a message in the chat. Oh, just smiley faces. Okay. Okay, you guys think about it. Keep it in your head, right? Think about questions. Type them up maybe and put them in the chat while we're waiting for people to come up with questions. Let's look at a question. Let's look at one together. Something I think is important. I'm sorry, I'm just getting a question here. Okay, actually, this is a good question. While I'm looking or getting something for you, I don't want to. How do I not share my screen? You'd think I'd know this by now, hey? Okay, it doesn't matter. So I have a really, really, really good question in the chat. And the question is, besides Unit 6, are there any written questions? And then the question was, like thermosetting plastics or thermoset polymers that you had in test 1. There are no written questions. You could probably thank Mr. Robin for that. He hates written questions, although I kind of do too. There are no written questions except for Unit 6. Guys, I cannot talk about Unit 6 anymore. If you have questions about Unit 6, please watch the YouTube video on from Thursday and go to the end. And the reason is I don't want to waste time on something that's not worth anything and will only take like 5 minutes of your time to study. If you're curious about Unit 6, go to the end of the YouTube tutorial on Thursday, okay? Everything is explained in that tutorial for Unit 6. I just don't think talking about Unit 6 is a good use of time in this tutorial. So I'm trying to open up an old final for you guys. I can see if I can find one here. I can find lots. Okay, now I can promise you that your final exam is brand new. So what I'm about to show you is not your final. But this is one that I gave in 2019 in intersession. And it does have some, now this is a pretty long one, but it does have some useful questions. Let's look at this question. Wink, 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 wink. Why can't I zoom out? Oops. Oh, don't worry about number 7 there on the right. That's not going to be asked. Okay. Let me check the chat before I do this question. Okay, whoa, I'm getting tons of questions here. Sorry. Okay, so Abdul Rahman, I hope I answered your question about Unit 6. I hope I wasn't rude. I just mean, I think we could do better things tonight than 6 because it's so easy. I have another private message about predicting the product of electrolysis that is not on this final exam. So this is, I don't know, we didn't do that, so I don't know why you're asking that question. There is no predicting products of electrolysis. Don't worry about it. That's a private message. So if for anybody who's like, what is he talking about? Just pretend I never said that because it's not on your final. Ahmed asks if there's a KSP question, will we solve it? Definitely. And I have another private message about Hess's law. So let's put a pause there and think about 3 questions. KSP, Hess's law. Well, actually, Ahmed, I don't know if you even care about KSP, but there will be one, yes. So let's look at this one. And the only reason I'm picking this one is because we didn't actually do this in the tutorial the other night, and this is a good practice one, wink, wink, nudge, nudge. On the graph above, sketch an energy profile that represents the uncatalyzed reaction. Include the following labels on your sketch. So I want you to show me reactants, products, enthalpy, activated complex, the activation energy, and tell me if it's endothermic or exothermic. And then part B says, show the effect of a catalyst. You guys had something similar to this well, we did this in class for sure. You had something similar to this on the first test, but this might be a good question to know. It's very easy. Well, kind of easy. The way that these graphs work is you have like a loop, it's going to look something like this. Obviously not perfect, but something like this. The key is, before you start, is to know if it's endothermic or exothermic. This is, of course, endothermic. So I just got a mark by saying that this was endothermic. Okay, endothermic means the energy of the products will be higher. It's absorbing. Oh, and by the way, if you don't know how I knew it was endothermic, it's because it's positive. So my reactants are here. I have my activation energy, and then my products are here. I mean, that's it. Now I just label it. Guys, you don't need perfect numbers. Like I do not care about the numbers of this graph, this is called a sketch. So very, very rough drawing. So my products N2O, my reactants N2 and O, right? I'm getting that from this equation. My enthalpy is right here, delta H. That was my positive 50 kilojoules. Okay, sorry about that, the pen there. My EA forward, again, I'm answering this down here. My EA forward is this right here. Don't worry about the word forward. EA just means activation energy. So it's the energy it takes to get that reaction to happen. And that was 120. I probably shouldn't use that anymore. Again, I got that from there. Let me try that again. Okay. Now, oh, and I don't think it's in this question here, but if you're wondering, this up here is what's called the transition state. Remember that from test number 2? All right, but there's one more question on this, one more really important question. What would a catalyst look like in this graph? What would the effect of a catalyst be on this graph? And all you need to do is show me, and I'm going to give you a very important definition here. So green is catalyst. So what does a catalyst do? A catalyst is a shortcut. A catalyst is something that lowers the activation energy of a reaction. It doesn't, and again, wink, wink, catalysts do not shift equilibrium. Catalysts just make reactions happen faster, full stop. That's the answer. Well, that's the answer to what a catalyst is. All right. Oh, and Hadil, yeah, thank you in the chat. It lowers the activation energy. Okay, cool, cool, cool. All right, I'm going to clear this slide here. I'm forgetting how to do. Oh, because I'm in Word. How do I clear this all in Word? I don't know. There we go. Okay, this is obviously going to be on YouTube, so if you didn't get a chance to write that down or like understand it, you can rewatch this. I'll put it up on YouTube right after this class. I just want to give you a hint. If you guys saw this slide open up a minute ago, number 7 here, this is not on your final. This was a very different time. So like, if you saw that appear on my screen, don't worry. That's not, we didn't do that. Don't worry. That's from many years ago. Hadil raised your hand. What's up? Do you have any questions?
Sir, Unit 1.
Yes. What about it?
Unit 1, Part 2, it have so many information.
What do you mean? Like, it has a lot of information, yes, but what is your question?
So the only important thing is like the comparison between thermosetting and thermoplastic and the...
Yeah, and homo and copolymers. Like guys, I have that's a good question, Hadil. I have on the D2L, I have a PDF. I'm brain dead after this week, and I've been doing so much work. On the D2L, there's a final exam review PDF, and it mentions that from chapter 1, you only need to know about homo and well, there's lots of things you need to know, but in terms of terms and definitions, homo and copolymers and the thermoset plastic stuff. Like, really follow that exam review. Like, trust me, it's amazing. And if you need more information about that final exam review, go to my YouTube and watch the video from Thursday. Okay, so I had a question about Hess's law. Let's do this. This question, it might have been a private message. I don't know, not that it matters. Let me just see. I hope that answered your question, Hadil, by the way. All right. Man, I am having some computer problems. Okay, so Hess's law. Definitely going to see one of these. Yeah, okay, thanks, Hadil. Perfect. And this was a private message, but I'm going to say your name anyways. Ali mentioned or asked me if I could show Hess's law, which I think is a great question because cough, cough, wink, wink, you might see Hess's law tomorrow. I mean, of course you are. Why wouldn't you? So let's go with green. Okay. Now, I did this in the tutorial on Thursday, so I'll go a little quick through this because, again, you really want to check out that tutorial. But the goal here is to match something in your equation above to something down here. And I had an email today from a student, and it was a good email. It was like, you often mention not to worry about oxygen, and that's true. And but there are exceptions. I mean, chemistry is crazy. Chemistry is chemistry. There's so many things and little exceptions, but this is one of those times. If that student's here, this is one of those times where I don't think I'm going to try to worry about oxygen. This is going to be hard to balance. I have 3 equations. Whoa, oh, sorry. Computer went a little cray on me there. There we go. I have 3 equations, and I have at least 3 chemicals that I can match. So for example, I have CS2. Oh, you know what I should be doing, guys? Should be using my highlighter. There we go. So I have CS2, and I have CS2 here. So that's a match. I have CO2 and CO2. I almost like writing in this better than PowerPoint. And then this is SO2 and this is SO2. Oh, wow, look at this one. Look how pretty those colors are too. Anyways, so what I need to do is I need to match these chemicals to the overall. So let's look at equation number 1. I need to make sure equation number 1 matches the overall. The overall is up here. Well, equation number 1 actually perfectly matches. So there we go. That's a gift to you. We don't have to worry about equation 1. There's 1 CO2 and it's on the products. Halas, finished. All right, let's try the next one. What about SO2? Well, SO2, there are 2 of them, and they are products. So what I'm going to do with equation 2 is I'm going to multiply it by 2. But that means I also need to multiply the enthalpy by 2. Like whatever I do here, I need to do to the enthalpy as well. And then on the bottom, this was a pretty easy one. This was a hard exam, but this was a pretty easy Hess's law question. I notice I have CS2 on the left and CS2 on the right. So I'm going to flip, which means flip here, which means turn this positive. Now what I do is I punch all of this in on my calculator and I get my answer. So I'm going to add, sorry, let me explain even further. I add these numbers together. Be careful that you multiply the second one by 2, and that's it. Halas, finished. I won't bother doing the answer, but I just add up these numbers and I multiply the second one by 2. If just let me give you a little hint too, by the way, if you did all of this, but you got this wrong, you messed up your calculator, you would get 4 out of 5. So you wouldn't get a 0, right? Like I don't mark, nobody marks like that, I hope. And Hadil, hey, lifesaver, used negative 900 kilojoules per mole. I think that sounds pretty good. Yeah, that looks pretty good. I'll trust you, and if it's not right, who cares? I mean, it's the method that matters. Okay, any other questions? I know Ahmed asked if we would have a KSP, but didn't ask if he wanted to see it done. Any other questions? Yeah, yes.
I mean the KSP, like the equation, like I have to solve it, the equation, or it will be like test 2.
Okay. Ahmed, how do I answer that? Well, you know what?
Because I have like I have problem to know how it will be the equation.
Okay. You know what? Ramadan's coming up. Exams are coming up. Let me show you. So this this is a gift, okay, everybody? This is something you can this is from me to you. The KSP question, unfortunately, again, like I'm not the only one who made the exam, and I don't mean that in a bad way. I just mean we had to put like two instructors' things together. The KSP question is very similar to this type of question. Oops, sorry. Where unfortunately we get 2 over here. So to answer your question, Ahmed, it is not like the test. It's like the other one, the harder one. So I would very happily show you guys how to do this. I don't know the number here. I'm going to make it up. I'm going to just say that the KSP for this equation is, let's say it's 1.5 times 10 to the minus 10. Yes.
Are you writing something? We can't see.
You can't see, darn. Okay, sorry. That made my my epic reveal less important. But yeah, this is the type of question. To answer Ahmed's question, it'll be like this one, not like test 1. Okay, so there you go. Hadil, addition polymerization. Yes, I can do that too. Okay, so let's very quickly do this one. So I'll do my little wink face here. I'm going to make a sad wink face because it is a wink wink moment, but this is a pretty tough question. KSP is the concentration of the products over the reactants. Whoops. But guys, I don't have any reactants here because they're solid. We don't put solid in your KSP. There is a problem though. I have a 2 in front of this. So I didn't mean to put the 2 there. The 2 goes right there. Sorry, my brain. And this 2 also means when I write my formula, I have X number of these ions and 2X number of these ions. So now what I'm going to do is I'm going to take this X and put it here, and this X and put it here. Okay, so KSP is this number. This is totally a made up number, guys, but it's 1.5 times 10 to the minus 10 equals X times 2X squared. Okay, now chemistry is over. This is math from now on in. So if you guys did math, 1700, I think the number is, this is just algebra. So this would be 1.5 times 10 to the minus 10 equals 4x cubed. And then you solve for x. Now, to solve for x here, again, a lot of people ask, and they ask this in class number on Thursday, the tutorial, where did the 4 come from? It's 2 squared. So this would end up being x cubed is 1.5 times 10 to the minus 10 over 4, or quite simply, x equals the cube root of 1.5. Again, this is not chemistry, this is math. If you guys aren't sure how to do cube roots, that's your math teacher's problem. No, but if you need help tomorrow in your final, like you don't know where the cube root button is on your calculator, I can show you that. I'm not interested in knowing if you can use a calculator. If you can show me that you know it's going to be a cube root, I can help you. So I have a couple questions moving on. I'm trying to go quick because I want to get as much in as I can. Okay, so Yeah, so Iman, we talked about this on Thursday, and I know you were there. I mentioned this on Thursday that when we did this in class, I left the 2 out, not the squared, but the 2 in front of it, and you can check that out on Thursday, on the Thursday's YouTube. You were there. I don't know if you were listening to me, but we talked about this on Thursday. But to answer your question, the reaction is definitely provided. You guys don't need to do any writing of chemical reactions except for, obviously the balancing in acidic conditions. Hadil asks if I can do an addition polymerization. Yeah, for sure. Now I just got to think where I could find one. Okay, I'm going to clear my screen here. I just going to give me a second here. I got to think. Let me clear my ink. Where can I find a good addition? I mean, I could go to my notes, but that's no fun, but I might have to. Okay, so I got Iman has a question from our worksheet. That's good. Let me think about an addition. Well, okay, like one of the easiest types of like addition polymerization is through a chemical that has a double bond. That's your class. Like, so we did a few types of polymers. Condensation polymers, wink, 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 is one to know. But an addition polymer or an addition polymerization can typically happen just through double bonds, where a monomer, for example, or it could be 2 monomers get together through reactions through alkenes, meaning the double bonds break and they kind of join together. So a good example of addition polymerization would be like PVC, which you obviously don't need to know the name of, but this chemical, if we added these chemicals together, now they might need an acid catalyst, or some of them might need light or heat or something like that, but we're not getting into that. Don't worry. That is for chemistry 2420. What would happen here is if I added these 2 monomers together, and I have regrets of making them so far apart from each other, but here, let me do this again. Sorry, I made them too far apart. Let's do a third one. Why not? Keep it exciting. Okay, so what happens is the double bond breaks. So guys, I'm over here on the left one. The double bond breaks and kind of reaches out to join this guy. This guy's double bond breaks. So they join together. This guy's double bond breaks, they join together, and you end up getting, so again, if I went back to these polymers here, if I added these chemicals together, I would end up just getting a straight carbon chain of 1, 2, 3, 4, 5, 6 carbons. And each one has 2 CLs. They've all added together. This is addition polymerization. The double bond breaks, joins onto the other molecule, and this is what you get. All right. I don't really care about the hydrogens, but you could put them in there if you want. Again, this isn't hydrocarbon chemistry. I'm not going to stress about it too much, but this would be an example of an addition polymerization. So boop, double bond joins, double bond joins. All right, Iman's question. I hope that helped. Waleed, I like the wink face you're putting in there. I'm starting to feel old. I grew up with emojis. Like I'm the generation that use like AOL or what is it? ICQ or what is it? Microsoft. I can't even remember the names of them. And we always have these emojis, but I find emojis hard to use in Zoom. Okay, Iman, what's your question from worksheet unit 5? And Hadil, what? I don't understand your private message there.
Third N, which means the repeating monomers.
Oh, no, you know, like no, all that N means is like if the N just means That it goes on forever. So like, sorry, I didn't mean to erase that, but the N just means that this, I shouldn't say forever, but it goes on for a long time. You don't have to worry about N. It's not a big deal. Good question though. But the N refers to that, like this chain could have 100 carbons. This could have 5 carbons. So Iman is asking, worksheet number 5. Sorry, worksheet from unit 5, and number 4, worksheet 4. Okay. Absolutely, Nor. Or sorry, yeah, no problem. Okay. Okay, so let me go to chapter 5 or unit 5. Give me a second to do this. I had a question while I'm loading this. I had a question the other day about you know, what would you study if you tonight you don't have much time, your exam's in actually 12 hours if you think about it. What would you study? Start with your tests, then go through the worksheets is what I would do. I mean, you don't have time to watch every YouTube video. Watching the tutorial might be a good example though. So if tonight you have a few hours, watch that tutorial and look over your tests. You'd be doing pretty well. Iman's question was, oh, somebody already asked that earlier. We didn't do that, so that's not a question. Guys, if you see a question in the worksheet that we didn't do in the notes, it's not in the course. Like, I cannot test you on something we didn't do. So if you're reading, doing, yes? Yes?
Can you scroll up a little bit?
Okay. Yeah.
Sure, it's in number 3, yeah.
We didn't do this, guys. We didn't do this. We did not do this section.
And sir, there is one.
Yeah.
It is like for the voltage, the A cell. We have something which has a battery.
Yep. Again,
is this gonna come?
Nope. If you didn't, if it wasn't in my notes, it's not going to be on the exam. So there's nothing about batteries. There's nothing about question 3, molten things. Nope. Not if I didn't do it in class, I cannot test you on it. But number 1 could be a good one, right? Number 1, 1A and B, definitely. 2, A, C, and D would be good, but don't do 3 or 4.
Sir, I have a question.
Yeah, for sure.
Now for the bridge, can we choose Na plus and C and Cl? I mean, yeah, Cl minus.
Yes. Okay, guys, this is important, and I want to mention this to everybody. That's a really good question. Let me just share a new screen. Okay. Give me 1 second. I'm getting a lot of questions now, guys, so I'm going to try to get to everybody before 7 or 8 o'clock. Okay. The question was, for the salt bridge, can you just use salt, as in table salt, NaCl? Absolutely. So guys, let me just give you a quick rundown of how this is going to work. You guys on your exam, and I told you this in class, we're going to deal with a galvanic cell, which means it's spontaneous, which means, of course, the E cell, it's going to generate voltage, so it's going to be positive. Okay, so the way that you can kind of wrap your head around this, I'm writing it a bit too big, is you're going to have a little picture on your final exam. Like, we're going to draw the cell for you. You guys have to fill in the blanks. So you're going to have a picture that looks like this, and then there'll be a salt bridge in the middle. Whoop. Okay. So this is my recommendation to you. Keep the anode on the left and the cathode on the right. That's my first recommendation to you, and I'll explain why. By always writing the anode on the left, and the cathode on the right, it means your diagram is always going to look the same. So no matter what chemicals I can give you tomorrow, your diagram is going to look the exact same. So it's going to be easy to draw. Like there's no way I could surprise you, for example. Let me just make my salt bridge a bit bigger, guys. Sorry. That just pen. Okay, as I drew it a little, maybe too big that time. So just remember that your anode is where oxidation occurs and your cathode is where reduction occurs. So let's pick some colors here. I'm just going to make up a metal. We'll call this metal X, so this is metal X, it's positive. This will be metal Y, that's positive. Your electrodes have to be positive. They have to be solid metals, I should say. Oh, sorry, yeah. I made a mistake. I got to fix that. I'll fix that in a second. Sorry, I didn't mean to say positive, guys. Ignore me. Forget that I just said that. I mean to say solid. It's been a long day. All right, so let's go green over here. So this one I'll just call Y. Again, it doesn't matter what chemical it is, but there's your solid. Okay, so the ion part of this goes in the solution. So my ion here would be positive, aqueous, and then this ion over here would be positive, aqueous. Metal ions are positive, right? So they're both going to be positive. So I'm almost there, and I know I'm answering your question. I don't know who asked this, but I'm taking like 10 minutes or 5 minutes to answer this question. Can you use NaCl? The answer is yes, but here's the key. Where do you put the NaCl? Well, you use the names to help you. Here are some examples of salt bridges. It could be NH4Cl. It could be KCl. It could be KBr. I recommend using NaCl. And the only reason I say that is because everybody knows that NaCl is a salt. So my salt bridge has salt. Put the cation in the cathode. Put the anion in the anode. And there you go. That's how you label it. Now, the last thing to label this cell is the direction of ions and, of course, my direction of electrons. Electrons always go from anode to cathode. So my electrons are going from anode to cathode, left to right, clockwise, And anode is oxidation, which means it's losing electrons. Cathode is reduction, which means it's gaining electrons. The cathode would be the reaction at the cathode would look like this. And the reaction at the anode would look like this. So the key is for this question, if you memorize, or not memorize, sorry, but if you know that the anode is on the left and the cathode is on the right, actually you can kind of memorize this. Like everybody take a mental picture of this, take a screenshot of, in your mind, take a look at this, and now just watch. If I erase these words, this is the template for your answer. You just have to put in the metals. And you might mix the metals up, but you're not going to get a 0. If you can draw this tomorrow, you're halfway there. Or not even draw, sorry, you need to fill in. You don't need to draw the actual thing, you just need to fill it in. But if you can, put this here, electrons go this way, all you have left to do is fill out the ions. Whew. Okay, let me check the chat. Okay, so any more questions? Any more questions? Or is it 7:45? Like honestly, I think the best thing for you guys to do now is, because I'm starting to answer questions that I've done before, is go watch that tutorial. Check out, look at your tests if you have them. I had a student, I'm just going to say this, there's a student writing me privately. I won't mention anybody's names, but they didn't pick up their tests from outside my office. If you don't have a copy of your test, maybe you have a friend in class that can take pictures with their phone and send you the test, like their version. Like you guys tonight, if you know, help your classmates out if they don't have a copy of the test. I don't care if you take pictures of it. Like it's not my problem anymore. So to this person writing me privately, I recommend maybe asking a class friend, because everybody's tests are outside my office and I can't go into work and you can't go into CNA. All right, anything else? You guys are so quiet right now. Okay, guys, I think, okay, oops, got a message in the chat there. Let's see what it says. Okay, I got a question now. Private message question, good quick question. Thank you to the student just writing me. The question is, what is the difference between chemical energy and thermal energy? That's a good question, wink, wink. Great question. What's the difference between, now, again, remember, you don't have to do any written answers except for chapter 6. So this type of question could be a good multiple choice. What's the or well, not that this is the question, but knowing the difference is important. What is chemical energy and what is thermal energy? Chemical energy is the energy stored in bonds. So like chemical energy is like the energy stored in the food you eat. You know, when you eat food, you consume what they call calories. Calories is the chemical energy, basically. You know, when you eat sugar or a chocolate bar or you drink, I mean, it could just be a sandwich, that's chemical energy. Chemical energy is stored in things like petroleum, stored in, you know, oil and gas. So when we burn it, we get energy from that. Thermal energy is related to chemical energy, but what thermal energy is related to heat. Thermal energy is the transfer of heat from something hot to cold. A good example of thermal energy is when you pick up a mug of coffee, or, you know, a cup of coffee. You go to Starbucks or Tim Hortons, you buy a coffee, it hurts your hands, it's so hot. That's thermal energy. The heat is going from the hot coffee to your hands. So long story short, chemical energy is the energy inside the bonds. And when we break the bonds, that energy gets released. Thermal energy is when heat transfers from something that's very hot to something that's cold. Whew. Anything else? Anything else? I got 12 minutes. Yes.
There is a question for balance and acid medium. Or no?
You want me to do that one?
Yes, please.
Okay, I was waiting for somebody to ask that. Because nobody asked it on Thursday, and I'm like, how is nobody asking this? This could be a good almost end of the session. Again, guys, I'll try to answer everything I can, but I do have to go, and you guys should be studying, not listening to me. But this is a good question. You guys know you're going to see a question like this on your final exam, right? I've told you, the other instructor has told you, his class, you're going to have to balance a redox reaction. Now, in the exam write-up, it does mention basic. We're going to have to do acidic because of just time constrictions. I don't know if that's the right word, time limitations. So here's an example from an old exam. I don't think yours is worth this much. I think yours is only worth 4. So it's not something I would freak out about. But here we go. Let's look at it. Okay. Step number 1. Identify what would your half reactions be. And what I mean, yes. Oh, I got to share my screen.
Yeah.
Yeah, you guys, you know, you've had enough classes with me. I usually don't have too many share screen problems, but I've been going, anytime I go from like D2L to Word to PowerPoint, I keep forgetting. So there you go. Here it is. Let me erase that and start over. Okay. So First thing you do when you see a redox reaction in acidic is identify what chemicals would be in your half reactions. It's easy. Find the metal or find, a chemical that they have in common. I don't know why this isn't working. I'm just trying to change the color of my pen. No. Hold on, guys. Something's going weird. I'm completely confused. Hold up. I'm having like crazy problems here. Just let me close. Sorry for the delay. Just let me close Word and let me try to open that again. It'll only take me 2 seconds here. Just, I don't know what happened. Okay, back to the final. Okay, so we're right to the end. Close, remove. All right, sorry guys, starting again. Okay, so these two are going to be part of my half reaction. These two are going to be part of my half reactions. So the first thing I do is write them down just side by side. I'm going to write a little small here. So I'm going to say MnO4 minus aqueous goes to Mn2 plus aqueous. I find the pen's a little thick. Let's make it smaller. Okay, and then for my other half reaction, I will go C2O4, 2 minus. So that oxalate, and then CO2 gas. Guys, one thing I'll mention, I'm going to make this a little smaller. And I've done this in class in front of people, out of all the years I've taught this, I've probably done these examples like 100 times. I just want to warn you, if you miss a number, like if you forget to put a 2 in or a 4 in or something like that, it's going to mess up the entire thing. So like, be very careful. Okay, step number whatever. I'm not going to label the steps, but after you write the half reactions, the next thing you do is balance every chemical except for O and H. So Mn, I have 1, Mn, I have 1. Notice I have 2 carbons here, so I'm going to put a 2 right there. That's, step number 2, I guess we'll call it. Okay. You just got a couple of marks, by the way. This isn't worth 7 anymore. We've knocked it down to 4, but you just got a mark or so for just doing this. Next thing you do, balance any oxygens with water. So I have 4 oxygens here. I'm going to add 4 waters over here. Okay, on the bottom, actually, if you notice this, I have 4 oxygens and I have 4 oxygens. They're balanced. I don't actually need to do anything with this equation on the bottom. It's good to go. This one's a pretty easy one, I think. Let me just double check to make sure that this is good. Yep, 4 and 4. Oxygen's good to go. Okay, next thing you do, any hydrogens that you have, you balance with H+. That's why this is called acidic. So, oh, sorry, guys. 4 of these, don't forget, because I have 4 of these. Okay, again, if you're wondering where the 4 came from for the water, it's because of the 4 here. 4 oxygens on the left, 4 waters on the right, which means I have to add 8 hydrogens here. Oh, one thing students have asked me in the past is, all these things you're adding, what phase are they? What do you put down? If you don't know what to put down, just put aqueous. You will never be wrong. The only reason I don't say aqueous for water is because aqueous is Latin for in water. So it's weird to say that water is in water, but I don't care. If you don't know what to put down in this question, just say it's aqueous. Okay, now we're at the hard part. I need to balance my electrons. So, you know, I'm following the law of conservation of energy. Electrons gained must equal electrons lost. And I don't have a balance of electrons here. This is probably the hardest part. Let's do the easy one first. I'll pick another color. I'm going to go with black for the electrons. So on this side, I have a -2 charge. On this side, I have a 0 charge. Well, if I want to balance these two sides, I'm going to need to add on this another -2. So I'm going to add here 2 electrons on the right. And now my charges are equal. You can calculate them again if you don't believe me. -2 and 0 plus a -2 equals -2. Done. Okay. So up at the top one, this, guys, I really need you to pay attention to this one. This one's going to be tough. The charge here is +7. Now, a lot of people ask me, I think we did this one in class or something similar. A lot of people ask, where did you get that 7? Well, there's 8 hydrogens and there's 1 permanganate ion. So 8 plus a -1 is a +7. This guy over here is a +2. There's no charge on water, so don't worry about him. Which means I need to add electrons over here. You always add electrons on the more positive side. Sorry. I think I like writing in Word better than I like writing in PowerPoint. That shouldn't be a thing. But anyways, okay. So add electrons to the more positive side. And this is the hardest part of this whole question. How do we get a +7 to equal a +2? Just add 1 electron at a time. So +7, let's add 1 electron, it becomes +6. Let's add another, +5, +4, +3, +2. If I add 5 electrons here, it will balance. Or, well, sorry, balance is the wrong word. I guess I should say it will cancel the charges. Guys, there's 1 step left. And I think I am going to stop after this, unless there's something really crazy somebody really needs. But I don't think you should be here listening to me. Go study, go practice, go look at some tests or watch that tutorial from Thursday. I did like so many questions there. But just to conclude, I'm not following the law of conservation of energy. I'm breaking the laws of the universe. How can one equation lose 2 electrons and the other equation gain 5 electrons? Electrons can't be created or destroyed. What's happening? Well, the problem is our math. It's not the universe, it's the math. So I'm going to multiply this one by 2 and I'm going to multiply this one by 5 to get my answer. Now, some of you might ask, where did you get the 2 and the 5? If you can't think of a number or like a lowest common multiple, they call it in math, just multiply the 2 of them together. So, you know, if you needed a lowest common multiple for 5 and 9, well, just multiply 1 by 9 and 1 by 5. So I had 2 and 5. I said, well, if I want them to be the same number, I'm looking for 10. So 2 times 5 is 10, and 5 times 2 is 10. And just to save time, because it is 7:59, my electrons will cancel. Oh, let me switch to another color. What's a cool color for canceling? Orange is a cool, purple is a cool color. Cancel, cancel. Now I add up what's left. And what's left is, be careful with the math, 16 hydrogens. Okay, 2 MnO4 minus, 5 C2O42 minus. I know this is pretty ridiculous, but like every chemistry student in the universe does this. I did it, you're doing it, your other teachers will have done it. Like, I think it's just like a cruel joke that every chemistry student does this. because between me and you, I've never seen it in real life. Anyways, if you're wondering where all these numbers in front come from, I'm just multiplying everything by the number in front of their respective equations. So finally, 8H2O and 10 CO2. Whew, gas. Finished. Alas, looks crazy, but there it is. Okay, so sorry, let me get back to some questions here. I have a private message Y7. Oh, okay, sorry. There's a question in the chat. Okay, sorry, there's two questions in the chat. I'm trying to read both at the same time. There's one question in the chat is, why is this side a 7? Or sorry, why is this a 7? To the person who asked that question, add together 8 and -1, and that's your answer. 8 positive plus -1, okay? To the other private, I kind of wish you guys didn't write me privately because I could say your names, because you shouldn't be ashamed of your questions. But anyway, it's too late now, or you'll never see me again after tomorrow. Regarding the polymers classification, will we only worry about cross-linking? I don't know. And I'd look at more than cross-linking. Look at some of the other ones. All right, guys, I'm going to answer this one last question, and then I do have to go. But to answer your private message, again, somebody asked for polymer classification. Do you only worry about cross-linking? Nope. I would look at some more. It's just a multiple choice question. It's only worth 1%. So sorry, I do have a public question. If that's what it says in the guide sheet, then that's what you can focus on. But I don't have the exam in front of me, and I don't want to just tell you to study something and then you get surprised tomorrow. But the guide sheet is definitely very good to follow. So Aisha, yeah, no problem. Thumbs up. The final exam is 50%. Somebody just asked 50. And the public question I have is, this is a good question, actually. I don't think this will be too important for tomorrow, but the question is, what is the effect of adding NaOH to this equilibrium? Okay, and the answer is, this is a really good one. I think this is straight from your lab, to be honest. This chemical is a base, and this chemical is an acid. So if you mix together a base and an acid, they cancel each other out. So what this is really asking is, what happens if you lower the concentration on this side? It's going to shift to the left. Again, the base removes the acid. The equation shifts to the left. Whew. Okay, guys. That's it for me. There was one question, or one student earlier asked me if we could speak privately after this. So you make sure you stay here. Thank you, everybody else. This has been recorded, so I'll put this on YouTube. I'll see you in the gym tomorrow. Have a great evening. We'll say hi and say goodbye tomorrow, of course. So thanks, everybody. Thank you, Ahmed and Abdullah and Yasmin and Aisha and Aaron and Noor and everybody.
Thank you very much.
Thank you so much. Have a great night. You can email me if you have questions.
Sorry.